Morning.
Maybe we'll just quickly introduce ourselves. I'm Grant Totten, and I'm with the R&D at Al Jazeera Media Network.
I'm Deirdre Temple with RT Television in Dublin, Ireland.
I am Gwendalina Cobianchi, and I'm with Vinova, video compression specialist based in London.
I am Maria Lodoria from Metaliquid, a computer vision startup.
So we're going to talk to you a little bit about our catalyst, which is called AI Content Indexing for Regulatory Compliance. So we're going to talk about what we're adding to the industry, how things are evolving, and how this is being applied to our particular use cases. So to give you an idea of those others that are involved, so Vinova, Metaliquid, Tech Mahindra, QCRI, and others are significantly adding value to various parts. I think the content just shut out. There we go. Yeah, so are involved in various parts of this. Tech Mahindra, for example, significantly involved in the fake news side of things that we'll be talking about. Vinova on the rapid metadata enrichment and so forth. And then the champions are 3 broadcasters. So let me go over our challenges. So for us, we have regulatory bodies such as Ofcom and others that require that we abide by certain types of content rules. For us, for example, we've got in Al Jazeera over 136 different compliance checks that we need to ensure we abide by, that the FCC and Ofcom and others, if we don't abide by those, then there are fines to be paid, there are licenses that can be revoked, and most importantly, especially in the case of content validation, children that need to be protected from certain types of content. So, and because we have lots and lots of video content, we have over 100,000 hours of video content that we need to produce. We do it in 5 languages ourselves, and RTE has content they have to go through, and so does Associated Press, who is part of this. And it's all very manual and labor intensive and can often get missed. Imagine going through 24/7 news content every single day across multiple properties. So in this particular case, you have people with stopwatches, as Deirdre will talk about shortly, who have to go through this. So what we said was there's a lot of work within the industry about moving metadata enrichment forward. And a lot of it's focused on content discovery and content. What we said is there's actually metadata that can be pulled off of here that can be valuable for contextualization. And we also, because we do it in live scenarios, we need to do it fast and accurately before it goes on air. Whether it's a post-production or a live scenario, we need to catch both. So in this video, for example, you can see that you've got the monuments in France, and you've got our presenter, and you've got a protest. And you've got the context of what that is. So that's what we're going to talk about today. So our goal within this catalyst is to intelligently and efficiently index media content so that broadcast and content owners can make sense of what's in their content. And obviously it's very AI driven, and this is kind of the focus of what we're doing. So there's 3 things that we believe is adding to the industry that others can take advantage of. One is something we call rapid metadata enrichment, which Gwenda will speak about shortly, contextual video analytics, and being applied, in this case, to regulatory compliance. So I'll hand it over to Gwenda. For us, as I mentioned, this is very important that we do it fast and accurately detect various parts of our video content. Gwenda?
Thank you very much, Grant. Does it work? Yeah. So in order to better understand the challenge, we analyze an example of the image indexing workflow of one of our sponsors, which is Al Jazeera. And typically, video analysis is the result of a trade-off between the speed and the processing that you throw into the analysis and the accuracy. So for instance, Al Jazeera only starts from a full HD video, but only analyze a very small sample of frames It's only iframes, right, Grant? So
Yes.
one every
Yeah, so
50
we may
frames.
go through one video, 20 minutes, maybe 100 frames or 1,000 frames. And so going through each image is quite...
Exactly. So you skip a lot of information because you don't have enough processing to do that. And also they start from a full HD video, 1080p, and they resize the video to 360p video because analyzing a 360p video is much lighter than analyzing a full HD video. However, of course, when you have to go into recognizing who a certain guy is, you need to get access to a certain level of detail. So it's a trade-off because you're missing something. So within the Catalyst, we decided to look in a completely new direction for video and image indexing, which is looking at innovative and radically new data formats. And this is the case of Vinova's Persus Pro codec. So imagine a format which includes natively into a single image all the possible levels of qualities and resolutions. And within this format, this is so flexible that if you want to access the top level quality and resolution, you can only access only the portion, the region of interest, which is interesting for you. Think about Google Maps as an example. When you zoom, you don't have to load the whole map of Nice, but you can actually zoom and only load the map around the exhibition center. That's exactly the way it works. So that we can perform each indexing task on the most appropriate resolution and level of quality without having to trade off speed and accuracy. So for instance, we can run quite accurate detection on a low level of quality and resolution. So I could detect people in this room even if I was looking at a very small image. However, in order to understand that this is Conrad, I really need to get access to a higher level of information. And so this is what we did with this Catalyst. It's the beginning of a journey, and we started with an initial experiment on a set of full HD frames taken from a video from Al Jazeera. So we run detection, which is basically recognizing whether that face is a face and not a ball, on a very, very small resolution, such as 240 by 135. And this is an example of what we got. So you can see an SD, sub-SD frame, in this case is a 360. You're still capable of detecting all the faces with the same level of accuracy of what you would do on a full HD video. So you don't actually need to analyze big images in order to be effective. In terms of recognition, which is really understanding whether that guy is Conrad, we have to get access to the top resolution. But we don't want to analyze the whole image because it would be a lot of processing. So thanks to the flexibility of the format, we can actually detect the region of interest during detection and then extract the data only corresponding to a small region of interest. For instance, in the case of our experiment, is a 224 by 224. So it's still a pretty small window. By doing that, if you see in this example, if we were to analyze a 360 video frame, we could probably be able to recognize only little faces, only Emmanuel Macron in this example. While if we increase the resolution, actually more details will become available and that increase accuracy. So during this Catalyst, we've been working with Metaliquid and Maria in particular. They have video analysis tools, state-of-the-art, with their own trained CNN network, which have been integrated to work with Persus Pro technology so that we joined forces to make image indexing more accurate and more efficient. The results of the first experiments are, I would say, amazing, and I think it gave us a lot of energy to keep working together on this. So we started on a sample of roughly 500 Full HD frames. We compressed using Persis Pro technology. That, by the way, compresses better than JPEG. So by doing that, we reduced the total size of the images by 43%, which is quite handy because if you have a distributed environment with images that need to be transmitted over the cloud, actually you save time even in transmission. And we focused a lot of attention on face detection because we realized that in terms of speed and processing, detection is really what makes the difference. In this experiment on JPEG images, it was 25 times higher than the speed, than the processing of recognition because it works on a much bigger number of pixels. And so detection is really where to look for to save processing. And we compared two scenarios. The baseline was working on Full HD frames converted to JPEG, so the red area that you see here, where basically the Metaliquid algorithm ran both detection, face detection and face recognition on 1080 resolution. And then we compare the results in terms of speed and accuracy of working with Persis Pro, where we performed detection on a 240 by 135. And then we moved up for recognition to the most appropriate level of quality, depending on how big was the face compared to the overall image.
And the area of interest.
And only on the area of interest, right. Yes, exactly. So, results is, I would say, pretty interesting. We saved 55% of the total processing by using this approach, which is over 2x speed up, which is, I mean, massive for our sponsors because it could enable new live scenarios, or it could enable them to analyze more frames on higher qualities so that they can improve the accuracy. And also for some of the other sponsors like Associated Press, who has a huge image archive, which is about to be massively indexed, it means actually saving a lot of money. So, and what happened to the accuracy? Well, the accuracy was not at all impacted. So we achieved these amazing results without affecting the accuracy, which is still at 93% level, which is state of the art.
And I think what's exciting for us is we can now apply this not only to faces, but we can apply it to other images that are on. Imagine somebody holding up a placard and you want to be able to read that and detect it quickly. Monuments, the White House, any other locations.
And then, of course, it applies to the media sector, but it has a much broader application on, security, for instance, thinking of the previous presentation. And so, over to you guys to continue on the use case. So how are we going to apply all this?
I can speak from here, I think. As I told you before, we are a computer vision startup, Metaliquid, and what we do is basically to extract metadata information, time-coded metadata information from video contents. And we are able to work both with archive video contents or live streaming, and we do artificial intelligence and neural networks algorithms to extract metadata information, and we have several services and functionalities, and we are able to extract time-coded descriptive metadata, such as JSON file that you can integrate in other softwares useful for your workflow, for example, production softwares or MAM systems or whatever. And next slide, please. So these are all our functionalities available at the moment. All of them are out-of-the-box services, and we are able to not only detect static concepts such as a face in a frame, but we are also able to understand what is happening and recognize actions, highlights, violence scenes, and in this way we can mix all the information, so we can join information about who is appearing, who is speaking, what is happening, to do a proper contextual analysis. And we have developed our proprietary, yes, next one, please. We have developed our proprietary deep learning framework. We don't really own open source framework because we would like to be fully customizable for our customer needs, such as for this catalyst. We mix all our services to prepare regulatory compliance issue, and we are able to also broaden our classes of recognized concepts very easily in few days. So the next one, all of our analysis can be run in real time, and also, of course, with Vinova, we are able to be faster and more accurate.
So I said this is exciting for us because now we can apply this in a live scenario. Live coverage. So with that said, we also, for this particular use case, looked at something we call contextual video analytics. And the idea is to take that rich metadata, and we're going to show you some examples. So when we talk about metadata, we want to just clarify that before we go into the use case, which is that video right there. What do you see in the video? Well, typical scenarios will call that a group of people instead of a protest. We want to distinguish that that's a protest as opposed to a group. That allows for better analysis. We can detect our presenter and so forth. So what do you get from this? The action detection, it's a protest. The object, that's the statue Marianne for the Gloire de la République Française. We can detect the Aston here at the bottom. And so now we're getting rich content that we can use. We have the speech to text. So what we do with that metadata is essentially extract that metadata, utilizing various types of knowledge graphs and, of course, NLP. We are able to extract various types of things like the context. Now I can tell you, what is the context of that protest? Well, that protest is about climate change. What's the bias? For climate change or against climate change? We can also tell you that that monument is in France. So now I can tell you how much coverage I've given in Paris, how much cover I've given with France. Have I over-covered France or under-covered it? I can tell you more about the presenter and so forth. So there's a lot of, let's say, enriched metadata that becomes very valuable. So we're going to go through some examples, and I'll ask Deirdre to come up to talk about some of the bias detection work that we've done. We'll talk about some fake news, maps detection, and all of these go back to that regulatory compliance model that we discussed. So maybe I want to talk about this one.
But I'm going to lead it myself, and I believe that
I'm just
if
going to let
the
it play
President
for a little
applies
bit.
the pressure, we can get the funding for these issues.
Okay, but I mean, childhood obesity is a major, major, major health issue, one which the government, I think, is running programs on. I mean, what are you going to do that's additional to that?
The reason I'm committed to it, David, is I'm somebody who with...
Jumping on the coattails of
Okay,
mental
so
health,
this
the
is an
aging
example.
population.
I think we made mention earlier about, as a public service provider, we have strict guidelines that we have to adhere to, especially in terms of regulatory compliance. One of those is if we have an election or if there's a referendum. As a public service provider, we need to show that we're giving a fair and balanced coverage for all parties involved or for both sides of the debate. And currently, in order to measure that and report on that, we use, it's very manual, it's very labor intensive. We actually use stopwatches whenever there's a debate such as this, to make sure that we're accurately recording whenever somebody's speaking. So we need to show if it's an election that each party is being represented fairly, or if it's a referendum that both sides of the debate are being represented fairly. But even though it's a manual process, that's prone to error, obviously, because if you have an example of two people talking at the same time, one person might stop recording that as a speaking time, but another person might have a bit of bias towards one party or another, and they will keep recording one party over another. So what we wanted to do as part of this catalyst was become more accurate, be able to report as efficiently as possible and do it as quickly as possible. So the example here is where we can have our speech and facial recognition and auto recording how often and how long somebody's speaking for. Facial recognition isn't enough on its own, or speech not enough on its own, because we need to show if somebody else is being shown on the TV screen, they might not necessarily be talking, but we want to measure exactly how long somebody is speaking for. To be able to do it in this way is a real game changer for us, because we've gone from somebody using stopwatches to something like this, where we can do it accurately and quickly. So it's a huge leap for us.
And I think what's exciting for us is Tech Mahindra, QCRI, Metaliquid, and others are helping us to understand what is bias. And they're working really hard, and at IBC we're going to be showing more examples of bias detection that Tech Mahindra is working on, that QCRI and MIT are working on, to essentially dig into this problem a bit more and come up with techniques. Another area that we're focused on, and again this is really kind of the focus of Tech Mahindra and QCRI and MIT, is factuality of reporting. So we talked about bias. Bias could be the one that Deirdre just spoke about. It could also be which way we're leaning on any particular story. So again, back to the contextual video analysis, it helps us to analyze, are we being fair, right? Are we not being fair? And we can go back. Companies have had their licenses revoked by Ofcom simply by being biased one way or the other. Think climate change. If you're pro-climate change, against climate change, hopefully most people are pro-climate change, then you can see how important that becomes. Climate change, as an example. So you can see that in this particular case, this is Al Jazeera's using that algorithm that we came up with, that we're kind of on the pro-climate change side, but we have to be telling the story, both sides of the story. So that is where that comes in. Maps utilization is another thing. We use lots and lots of maps. And the challenge with maps is that we produce a lot. It can get us into diplomatic challenges. An example is Morocco has a disputed area, and there's actually a dotted line that you're supposed to put according to the UN. Okay? At what point somebody put a solid line? Imagine the diplomatic outcry. Okay? So you can imagine if I don't detect that and somebody else detects it, then we have issues. We have calls that are made generally. So another example is there are some cities in Syria that are unknown. If our speaker is talking about Halab, which is up here, but we showed Damascus, I'm using speech to text to detect that we spoke about Halab, but actually I showed Damascus, OCR. So you have various techniques, we put them together, and we can figure this out. And because of Vinova and Metaliquid, we can do that at a fast pace and catch it before it goes on air. This is another example of a map usage related to India and another border dispute, such as Kashmir.
He accelerated it to August 15, 1947, and with that, a headlong rush into disaster happened, with the British unable and unwilling to prevent some of the horrors that were unfolding before their very eyes.
Horrors unleashed by hastily drawn lines on a map. The northwest state of Punjab was home to Hindus, Sikhs, but mostly Muslims. It was split, with one side forming the bulk of Pakistan.
Imagine we get that line wrong. It's, so we try to say by the UN standards of what the maps are, when there's border disputes. So that kind of gives you the map context. The other one is content moderation. And I do warn you, the next one is slightly graphic, but we've tried to tailor it back. So you can understand that children should not be viewing certain types of things before the watershed period, according to Ofcom, right? So I'm going to show you an example where we need to be able to identify automatically when to put this kind of warning up, or when not to show it, because some things should not be shown. But there's a big debate because some things need to be shown to tell the story. So again, it's a very challenging exercise. This is something that happened in Venezuela just last week, and I didn't show the rest of it, but something bad happens. If that is shown to children, it's bad for them. That's the most important thing. And second of all, if it is played before the watershed moment, we can be fined and our license can be revoked.
And Grant, just if I may, it's not just about, obviously it is about the children as well, but it's about just giving the warning up front, or even having the warning while you're playing it. So yeah, exactly to your point. And how much of a warning do you need? Because do we need to show the violent content? Do we need to show something controversial? And how much of a warning pre, during, and after do we need to give our audience? Because there are some things we do not want to show, but we have to show.
That's right.
So, yeah.
And what's interesting is this is action detection. And again, it goes back to VNova and Metaliquid's capabilities that allow us to detect that. But additionally, we may be speaking about it as well. So we need to do some speech-to-text analysis. This is the final one. So again, we've just picked a few. We have about 135 different things we need to detect, but we just took a few. This one is a basic compliance detection for our own needs internally, is we have to make sure that the person speaking here, face detection, and the person written here, we didn't make a mistake post-production. So at the end of the day, we do some analysis there. We also use some knowledge graphs to make sure that this content is actually correct after it goes on air. So just to recap, we have rapid metadata enrichment that Gwenda and Maria spoke about, contextual video analytics, and being applied to things like fake news that Tech Mahindra is working on, things like maps and others that are being used. And we hope in IBC that we'll have a lot more to show. If you want to come visit us at the demo booth, you can see some of this stuff in action. Thank you very much.